Mercury. Mercury is the planet closest to the sun, but if you think that makes it blazing hot all the time, you're wrong. At night, the temperature drops to around minus 290 degrees Fahrenheit. During the day, though, it skyrockets to about 800 degrees Fahrenheit. This extreme difference happens because Mercury doesn't have a thick atmosphere to balance out temperatures. Instead, it only has a thin exosphere, which can't trap or spread heat. While you wouldn't need to worry about storms or rain there, the real dangers are intense solar radiation and the complete lack of oxygen. Mercury gets nearly 7 times more sunlight than Earth does. Being the smallest planet in our solar system, its surface is packed with craters, cliffs, and rough terrain, which makes landing very difficult. The lack of air resistance makes it even harder. Slowing down a spacecraft becomes a real challenge, raising the risk of a crash. Trying to land during the day is nearly impossible because of the scorching heat. NASA's current spacesuits can only handle up to about 250 degrees Fahrenheit, nowhere close to Mercury's daytime peak of 800 degrees. And since one Mercury day lasts almost half a year, due to the slow rotation, nights aren't much safer either. Temperatures of minus 290 degrees Fahrenheit fall well below the suit's limit of minus 250, which means you'd still freeze. The best option would be to land in the Terminator zone, the boundary between day and night where temperatures are more moderate. But even there, conditions change fast, making survival very risky. Venus. Venus is our closest planetary neighbor, sitting only about 40 million kilometers away. In theory, that means getting there wouldn't take long. Maybe just 4 months of space travel. At first glance, Venus looks a lot like Earth. Its size and gravity are surprisingly similar, but the real dangers reveal themselves as soon as you approach the planet. Those glowing yellow clouds hanging in the atmosphere? They're not made of harmless mist. They're packed with sulfuric acid, a chemical so corrosive it would burn through your lungs in seconds if you breathed it in. Even with an advanced spacesuit filtering the toxins, as you descend, the air gets unbelievably thick. Made almost entirely of carbon dioxide, visibility would drop fast, leaving you nearly blind in a dense orange haze. The surface of Venus is a blistering 450 degrees Celsius, hot enough to melt lead. And even though the planet is closer to the sun than we are, barely 10% of sunlight actually reaches the surface. The rest is blocked by the heavy clouds, so the ground would feel dim and shadowy, like an endless sunset. Moving around would be a nightmare. Gravity feels normal, but the atmosphere is so dense, it would be like walking underwater. And the final killer? The pressure. On Earth, we live under 1 bar of pressure at sea level. On Venus, it's closer to 92 bars. Within seconds, the crushing force would overwhelm even the strongest spacesuit. If the pressure didn't destroy you immediately, your suit would fail, letting the sulfuric acid in. At that point, it would be over in seconds. Mars. Mars is the second closest planet to Earth and the most likely to support life out of all 8 planets. Daytime temperatures aren't nearly as extreme as on Mercury or Venus, sometimes climbing to a fairly comfortable 68 degrees Fahrenheit. But the real challenge comes at night, or in certain regions of the planet where temperatures can plummet to around minus 243 degrees Fahrenheit. Another major issue, just like on Mercury, is Mars' incredibly thin atmosphere. It's made mostly of carbon dioxide, with only trace amounts of oxygen, meaning there's hardly any breathable air. This thin atmosphere also leads to low pressure and high radiation exposure, both of which are extremely dangerous. On average, natural radiation on Mars measures about 24 to 30 rads. That's roughly 40 to 50 times higher than what we experience on Earth. On top of that, Mars is hit by frequent, massive dust storms, with wind speeds reaching up to 60 miles per hour. These storms pose serious challenges, so any attempt to live there would need a fully sealed, insulated, and reliable life support system. Jupiter. Jupiter is the biggest planet out of the 8, and it's one of the hardest planets to land on primarily because of its extreme radiation levels. Even 186,000 miles away, the radiation would start penetrating your suit and you'd be done for. But since that's a boring outcome, let's assume you have a hypothetical suit that can block the radiation. Jupiter's gravity is 2.4 times stronger than Earth's, meaning you'd be falling incredibly fast. As you enter the first layers of the atmosphere, you'd encounter white clouds made of frozen ammonia, crystals with temperatures around minus 238 degrees Fahrenheit. The winds here are no joke, reaching insane speeds of up to 300 miles per hour. If you manage to descend about 93 miles through these top layers, you'd reach the deepest point ever explored. This is how far NASA's Galileo probe got back in 1995. Beyond this point, things start getting darker and both temperature and pressure increase rapidly. Just as a fun fact, the pressure near Jupiter's center is estimated to be about 100 million times Earth's atmospheric pressure. After hours of falling, you might reach Jupiter's inner layers, where you'd encounter a supercritical fluid, a state that's not quite liquid but not gas either. Here you'd kind of be swimming in this bizarre substance. If you continued further toward the center, you'd encounter metallic hydrogen, an extremely dense liquid that would trap you. But if you somehow managed to get through that, you'd reach Jupiter's core. Though we're not entirely sure if it's solid or not, the temperatures here would be about 43,000 degrees Fahrenheit, roughly 4.5 times hotter than the sun's surface. Saturn. Saturn is the second largest planet in the solar system, with an atmosphere primarily made of hydrogen and helium. The first challenge would be avoiding a crash with one of its 146 orbiting moons. Once you manage that, you'd encounter its iconic rings, which are made of debris from old moons, ice pellets, comets, and asteroids. Let's assume you're either an incredibly skilled pilot or your spaceship is indestructible, so you don't meet your end by smashing into space junk. As you approach Saturn's equator, you'd witness an incredible spectacle of red and purple auras caused by highly energetic hydrogen in the atmosphere. Also, hurricane force. Winds blasting at speeds of around 1,100 miles per hour would make it nearly impossible to stay steady. Trying to enter from the North Pole wouldn't be any better. Up there, you'd face a massive storm so large you could fit 2 Earths inside it. This region also has ammonia clouds, similar to Jupiter's, and temperatures that can plummet to a bone, chilling minus 418 degrees Fahrenheit. As you fall deeper through the layers of clouds, the temperatures would start to rise again, eventually reaching 32 degrees Fahrenheit at this point. While the cold becomes less of an issue, pressure becomes your biggest enemy. It increases to levels comparable to the deepest parts of Earth's oceans. Continuing further, the gases around you would transition into a liquid state. If you somehow survived long enough to reach the center of Saturn, you'd encounter its molten rocky core, which is about 10 times the size of Earth. Temperatures here reach a scorching 21,000 degrees Fahrenheit, more than twice as hot as the sun's surface, with pressure roughly 1,000 times greater than Earth's. Neptune. Neptune is the second ice giant after Uranus, and its composition is very similar, being the farthest planet from the Sun 30 times farther than Earth. It is incredibly dark. Like Uranus, Neptune is extremely cold in its outer layers, but the inner layers are intensely hot due to immense pressure and heat from its core. Matter of fact, its core is about 12,632 degrees Fahrenheit, which is hotter than the Sun's surface. It also experiences the famous diamond rain caused by high pressure, breaking down methane and forming solid diamonds. Neptune's winds are among the strongest in the solar system, reaching supersonic speeds. In many ways, it is basically a twin of Uranus, so there isn't much to add. If you liked this video, subscribe for similar ones. Uranus. Uranus is where planets start getting really far from Earth, making the journey incredibly long. Uranus is one of the 2 ice giants, and the only planet in the solar system that spins on its side. It also rotates faster than Earth, with a day lasting just 17 Earth hours. By the way, being an ice giant doesn't mean the planet is a solid ball of ice. Instead, it means it's primarily composed of elements heavier than hydrogen and helium. Like Saturn, you'd need to avoid crashing into its rings. Once you pass them, you'd find yourself surrounded by toxic gas, and the temperature would drop rapidly to below minus 328 degrees Fahrenheit. This makes it the coldest planet in the solar system. If the freezing cold and poisonous atmosphere didn't get you, you'd descend through the first layer of the atmosphere. Here things get even worse. The air becomes dense, and you'd be pelted by ice pellets. Eventually, you'd reach something truly spectacular, a rain of diamonds driven by winds of up to 560 miles per hour. The pressure here is about 100 times greater than Earth's, which would ultimately crush you.